Hi, welcome back to my channel. My name is Gina. In this video, we'll talk about a technique to solve an integral that is not a basic antiderivative, the u-sub. When do I consider using the substitution? First, when the integral is not a basic antiderivative. Second, if the integrant is a composition function, meaning when you have a function inside another function. And third, if there's a function u, whose derivative u prime also appears in the integral. I will talk about the procedure while we do this example together. Integral of 2x plus 1 times cosine of x squared plus x plus 6. The first step is to rename a function within the integral as it. And the tip to find the function u is to look for inner function of a composition function. And you also want to have a u such that its derivative also appears in the integral. And the third tip is when you have a fractional function, a lot of times you can rename the denominator as the u. In this example, we have an inner function inside the cosine function. So let u be the inner function, x squared plus x plus 6. Then the second step, we are going to replace the dx into du by obeying the property u prime equals to du over dx. So du is u prime times dx. The u in this example is x squared plus x plus 6. So du, which is u prime times dx, it is 2x plus 1 times dx. Then the third step, using the first and the second steps, we are going to rewrite the integral in terms of u. The initial integral is cosine of x squared plus x plus 6 times 2x plus 1 dx. And we renamed the inner function u, and we found that du is 2x plus 1 times dx. So we can rewrite the integral as integral of cosine of u du. And integral of cosine of u is sine of u. And remember to add a constant at the end. And the last step, we can substitute the u back to the equation. So this integral equals to sine of x squared plus x plus 6, which is our u, and plus some constant at the end. Now let's look at this example. Integral of line of x squared over x. Remember that the derivative of line function is 1 over x. So that is the hint to let u equals line of x squared. So du is 1 over x squared times derivative of x squared using the chain rule and times dx. So this equals to 1 over x squared times 2x dx, which is 2 over x dx. So this integral equals integral of line of x squared times 1 over x dx. But the du is 2 over x dx. So we want to times a 2 to complete the du, but also we need to divide it by 2 so they can cancel each other out. So this integral equals 1 over 2 integral of u du. Since this is our u and this is our du, an integral of u is u squared over 2. And remember to add some constant at the end. Now let's substitute the u back. So this equals 1 over 4 times ln of x squared plus d. Warning: when you are evaluating a definite integral, it means when the bounds are specified. Then when you use the u-sub, you also have to change the bound. For example, integral of x times e to the power of x squared from 1 to 3. In the integrand, we have a composition function, e to the power of another function of x. So let u be the inner function, x squared. So du would be 2x dx. And remember, we have to change the bounds. The upper bound, when x equals to 3, using our definition of u, which is x squared, so when x equals to 3, u equals to 9. And the lower bound, when x equals to 1, u equals to 1 squared, which is 1. So this integral equals 1 over 2 times integral of e to the power of x squared times 2x dx, evaluated from 1 to 3. Now we can use the u-sub. The x squared is the u, and 2x dx is the du. So this equals to half times integral of e to the power of u du from 1 to 9. An integral of exponential function equals to the exponential function. Which equals half times e to the power of 9 minus e to the power of 1. That is the end of the video. If you are interested in learning more Calculus 2, I have an online course on Calculus 2, and I'll put the link down below. If you like my videos, please like and subscribe, and I'll see you in the next video.